Hello everyone, myself Komal Shirsat. I am final year student of Shivajirao S. Zondre College of Pharmacy, Asangaon. Today I am going to explain you about the soft gelatin capsules with my coordinates Shivani, Swapnil and Dipali under the guidance of Dr. Nitin Moire, professor and principal of our college. Let's start with the topic soft gelatin capsules. First, we should know what is capsules. Capsules are solid dosage form in which drug substance is enclosed with hard and soft soluble shell. The cells are generally formed from gelatin. Capsules are of two types hard gelatin capsule and soft gelatin capsules. Soft gelatin capsules. Soft capsules are single unit solid dosage form. They are drug delivery system made up of liquid or a semi-solid matrix inside a one-piece outer gelatin shell. Soft gelatin capsules are one-piece hermetically sealed soft gelatin shells containing a liquid or a suspension or a semi-solid. Soft gelatin is a mainly composed of gelatin, plasticizers, preservative, coloring and opacifying agents, flavoring agents and sugars. Example, cyclosporine capsules. Next we'll see what is gelatin. Gelatin is a heterogeneous product derived by hydrolytic extraction of animals' collagen. The sources of gelatin including green bones, hide portions and frozen pork skin. There are two types of gelatin. Type A, derived from acid treated precursor that exhibits the isoelectric point at pH 9. It is manufactured mainly from pork skin. Next, type B, derived from alkali treated precursor that exhibits an isoelectric point at pH 4.7. It is manufactured mainly from green bones. Advantages of capsules. Capsules are tasteless, odorless, and can easily be administered. Combination of powders we can use. They are attractive in appearance. The drugs having unpleasant odor and taste are enclosed in a tasteless shell. They can be filled quickly and conveniently. They are economical. They are very easy to handle and carry. Disadvantages of capsules. Special conditions are required for their storage. Soft gelatin capsules are highly sensitive to moisture. Soft gelatin capsules having difficulties in dealing with the effervescent and delicescent materials. Manufacturing powders of soft gelatin capsule is complex as compared to the other dosage forms. Slide is capsule size. Soft gelatin capsules are available in various shapes and sizes. There are oblongs, ovals, suppositories, round shapes, special shapes of soft gelatin capsules are there. Next, we'll see manufacturing of soft gelatin capsules. Soft gelatin capsules are manufactured by four methods. First, plate process. Second, rotary dry process. Third is Accogel machine. And four is reciprocating dye.
First, plate method. Place the gelatin sheet over a die plate containing numerous die pockets. Application of vacuum to draw the sheet into the die pockets. Fill the pockets with liquid or paste. Place another gelatin sheet over the filled pockets. Sandwich under a die press where the capsules are formed and cut out. Second, rotatory dye method. In this machine, the soft gelatin capsules are prepared and then filled immediately with liquid medicaments. It is having two hoppers and two rotating dies. Liquid mixture is placed in one hopper and the liquid medicament in other hopper. The two rotating dies rotate in opposite directions. When the fluid gelatin mixture enters the machine from the hopper, it produces two continuous ribbons. This half shell of the capsule is formed. At this stage, the measured quantity of the medicament is filled into it with the stroke of a pump. With the subsequent movement of the dies, the other half capsule is formed. This is diagram of rotatory dye method. Third, Accogel machine. It consists of mainly three parts: measuring roll, die roll, and sealing roll. This is another rotatory process involving the measuring roll. A die roll and the pockets in the two rolls are aligned with each other. The powder or granular fill material is held in the pockets of the measuring roll under vacuum. A plasticized sheet is drawn into the die pockets of the die roll under vacuum. As the measuring roll and the die roll rotate, the measured dosage are transferred to the gelatin line pockets of the die roll. The continued rotation of the field die converges with the rotating sealing roll, where second gelatin sheet is applied to form the other half of capsule. The pressure developed between the both rolls seals and cutout of the capsules. Fourth, reciprocating die method. This is similar to rotatory process but is differ in the actual encapsulating process. The gelatin ribbons are fed between a set of vertical dies that continuously open and close to form the rows of the pockets in the gelatin ribbons. These pockets are filled with the medication and are sealed, shaped, and cut out of the film as they progress through the machinery. As the measuring roll and die rolls rotate, the measured dosage are transferred to the gelatin link pockets of the die roll. The continued rotation of the field die converges with the rotating sealing roll, where a second gelatin sheet is applied to form the other half of the capsule. Pressure developed between the die roll and sealing roll seals and cuts out of the capsule.
Then, packaging and store. Capsule should be packed well closed glass and plastic container and stored at a temperature not exceeding 30 degrees Celsius. Capsules are individually protected by enclosing in a strip and blister packaging. In a strip pack, the capsule is hermetically sealed with a strip of aluminum or a plastic film. In a blister pack, a press on the blister forces the capsule through the packing strip. Capsules have a larger shelf life unopened glass bottles than in a strip pack but this is the reverse. Nowadays, capsules are strip pack which provide sanitary handling of medicine, ease in count and identification. Plastic bottle with screw cap, then clam shell blister pack, plastic pill bucket, plastic pouch ziplock. Then capsule sealing. Tamper evident capsule by sealing the joining between the two capsule parts. Disintegrative looking capsule by sealing them with color band of gelatin. If remove the band cannot be restored without expert sealing with gelatin through a heat welding process that fuses the capsule cap to the ring out. The capsule were heat welded. Example, weld gelatin seal.
Let's introduce about cleaning and polishing capsules. On a small scale, capsule may be cleaned individually or in small numbers by rubbing them with clean gauze or a cloth. On a large scale, many capsules filling machines are fixed with a cleaning vacuum that removes any extra venous material from the capsules as they exit the equipment. Industrial cleaning and polishing of fill hard capsules using the Acela-Cotta apparatus. Quality control of capsules. Quality control tests are divided into two types, that is physical test and chemical test. In physical test, disintegration test and wet variation test, and in chemical test, dissolution test, assay, content uniformity, stability testing, and moisture permeation test. Physical test of capsules. Finally, physical control processing and packing may be accomplished by the following in a line continuous operation. First one is a capsule diameter sorter allows to pass to the next unit of any capsule within plus or minus 0.020 inch of theoretical diameter. Second one is a capsule color. The capsule color are fed to it automatic from the diameter sorter by a pneumatic conveyor in the unit. Any capsules whose color does not conform to the reference color standard for the particular product is discarded or passes this test. Disintegration test. The disintegration test determines whether the capsule disintegrated with a prescribed time when placed in a liquid medium under the prescribed integral conditions method according to BP, and which applies to both hard and soft capsules. Introduce one capsule in each tube and suspend the apparatus in a beaker containing 60 ml water at a 37 degrees Celsius. If a hard capsule floats on surface of water, the disc may be added. Then operate the apparatus for 30 minutes and remove the assembly from the liquid. Then the capsules pass the test if no residue remains on the screen of apparatus, or if the residue remains, it consists of fragment shells. If a soft mass with a no palpable core, and if the disc is used, any residue is remaining on its lower surface should only consist of fragments of shells. Weight variation test. Proceed as a director under hard capsules, but determine the net weight of the content of the individual capsules as follows. Weigh the capsules individually, then cut and open the capsules. Next, remove the content by washing with the suitable solvent and allow the solvents to evaporate from the shells at a room temperature. Then weigh the individual shells and calculate the net content. Chemical test of capsules. Dissolution test. The dissolution test is carried out using the dissolution apparatus official in both the USP and IP. The capsule is placed in a basket and the basket is immersed in the dissolution medium and caused to rotate at a specified speed. The dissolution medium is held in a covered 1000 ml glass vessels and maintained at a 37% plus 0.5% by means of the constant temperature suitable water bath. The stirrer speed and type of dissolution medium are specified in the individual monograph. Here are some pics of observations of dissolution test. Initially, the capsules are dissolved in the water at room temperature. After that, the observations are taken randomly in a 0 minute, 3 minutes, 4 minutes and 10 minutes. After 10 minutes, the capsules are get fully dissolved in the water. This slide shows the condition of the capsules after dissolution in 0 minutes, 5 minutes, 10 minutes and 15 minutes. Result: 6 capsules are tested and are accepted if each of them is not less than monograph specified, that is P plus or minus 5%. If it is failed, then additional 6 capsules are tested. The result is accepted if the average of 12 capsules is greater than or equal to P, none of them is less than P minus 15%. If the capsule still fails the test, the additional 12 capsules are tested and are accepted if the average of 24 is greater than to P, if it not more than 2 less than P minus 15%, and none of them is less than P 25%. Bloom strength of a gelatin. Raw materials. The gelatin of the capsule shell should be assayed for various physical properties like home strength, viscosity, etc. Procedure. Gelatin is weighed into water to typically create a 6.67% solution in a standard Bloom bottles. The mix is then stirred and keep it for 3 hours at a room temperature. Bottles are placed in a 65 degrees Celsius bath for 20 minutes. Moisture permeation test. The degree and the rate of moisture penetration is determined by packaging the dosage unit together with a color revealing desiccant pellet. Then expose the packet unit to known relative humidity over a specified time. After that, observe the desiccant pellet for a color change. Any change in color indicates absorption of moisture. Then by measuring pre-test weight and post-test weight of pellet, amount can be calculated. Allow the bloom jars to cool for 15 minutes at room temperature. They then condition for 16 hours in 10 degrees Celsius water bath.
Then formulation. Consideration during manufacture of soft gel. Manufacturer should keep the following in mind when producing a soft gelatin capsule. First, compatibility of drug with gelatin. The content of soft gelatin capsule vary from solid, solid and liquid, solution or suspension, a combination of miscible liquid or a simple liquid formulation. Fill material are limited to those that do not interact with gelatin, shell and other component of shell. Then stability of the drug with moisture. The moisture content of soft gelatin capsule plasticide with glycerol is considerably higher than that of hard gelatin capsules. Therefore, to ensure chemical stability of the drug, moisture sensitive drug should not be formulated in soft gelatin capsules. Third one is stability of a drug at temperature 35 to 40 degrees Celsius. There is another important consideration in development of soft gelatin capsule. During encapsulation, fill material may be heated up to 35 degrees Celsius. Hence, thermoable drugs may not be encapsulated in soft gelatin capsules. Then, pH of fill material. Extreme acid and basic pH should be avoided because a pH is below 2.5 which tend to hydrolyze gelatin. Also, fill material with pH greater than 9 and aldehydes has tanning effect on gelatin. Tanning process involves cross-linking of gelatin which result in hardening of shell. The shell becomes insoluble in water and resistant to digestion by GI enzyme trypsin and chymotrypsin. Then the migration of a drug substance into shell. One of the most important aspects of soft gelatin capsule formulation is to ensure that there is a minimum interaction or migration between the liquid film matrix and soft gel shell. Drug substance can migrate from an oily vehicles into the shell and this has been recorded to their water solubility and partition coefficient between the water and the nonpolar solvent. The possible migration of a drug into the shell must be considered in the packaging of topical product in soft gelatin tube like capsule, as this could be affect drug concentration in the ointment as they apply for the other product such as the oral capsule or suppository capsule. Both the shells and contents must be considered in judging drug content when migration occurs. We are thankful to our President, Honorable Dr. Shivajirao Zonle Sir, Secretary Honorable Dr. Geeta Khare Ma'am and Principal Dr. Nithi Mohire Sir for encouragement and guidance, efficient use of social media to spread knowledge through making informative videos. Please like and subscribe our channel for such informative videos. Thank you.